Go ahead and get out your note sheet for 4-6 relations and functions. Okay, first thing we're going to look at is some vocabulary, and this really should be some review from last year, so hopefully it comes back to you guys. So first we'll talk about relation, and relations are just a set of ordered pairs. And then when referring to that relation in the ordered pairs, which are x and y values, the domain refers to all of the first coordinates, which are your x values. That's also your input. And then the range is all of your y values, which are the second coordinates in each ordered pair. And that's also called your output. So on your note sheet, you have an example of a relation, and it shows these 3 ordered pairs. And what we're going to do is just list the domain and the range values from this list of ordered pairs. And typically when you list them or when you see it on a multiple choice test, they're going to be in order from least to greatest. So if we look at our domain, these x values, you have 3, -1, and 0. In numerical order would be -1, 0, 3. And then the range, which are your y values, in numerical order would be -6, 2, and 4. So some extra practice here again, just looking at the relation that you see here with these 3 ordered pairs. We're going to go ahead and list the domain and the range. So the domain would be your x values. So we see 3, 1, and -2, and I'm going to go ahead and put it in numerical order. And then the range are your outputs or your y values, and in numerical order you should have 0, 2, and 6. And it's important that you use these braces instead of regular parentheses. With math, it does matter when you have parentheses versus braces for stuff like this. So try and get used to it. If you're not the best drawer of these, that's fine. It's kind of just squiggles anyway. Okay, so this one's not on your note sheet, so if you want to just press pause and practice real quick and then press play to see if you can identify the domain of this relation. Okay, so the correct answer here is actually option 3. And if anybody picked option 1, the reason why it's 3 and not 1 is because when you have the same value occur more than once, you don't have to write it out more than once. Domain's just saying what are all the different x values you actually see here. And because there's 2 4s, instead of listing it twice, we just see a 2, we see 3, and we see a 4 somewhere. So option 3 is the better of the 2. Go ahead and try this one. It says what's the range of the relation. Press pause and then play when you're ready. All right, so hopefully you didn't get tricked this time. So the answer should be option 4, just 1, 2, and 3. And again, it's because you have that repeated 1. You don't necessarily have to list it twice when you're just listing the different values of the range. This is just a nice visual look at domain and range on a graph. So domain is that x value and range is your y values, which is your height and up and down. So we're going to look at relations represented in different ways, and there's 4 different ways that you can see a relation. One could just be your basic ordered pairs, which is what we've seen so far. You also may see them in tables. You may see a relation in a graph, which means you actually have the ordered pairs graphed, and then you also may see a mapping, which we'll take a look at here in a second. So this one's not actually on your note sheet, so if you kind of want to just pay attention, what we see here is a relation, but it's represented in a table. So we're going to actually write out the other ways right now, and then if you watch this one, you are going to do the same thing here in a second. So my relation would just be listing all of this information as ordered pairs. So I have -1 and 3 together. I have 0 and 6. I have 4 and -1. And then I have 7 and 3. So as ordered pairs, that's how it would look. And then whenever I want to list just my domain, I'm going to list just my x values, which is nice because they're already in order in the table above. And then when I want my range, I'm going to list them, and that would be -1, 3, 6. Again, I don't have to repeat that 3 twice, so that would be how that works. Now, the mapping, what it is basically you have one little spot for x's and then a spot for y's. So I'm going to go ahead and write all of my x values first. And then I'm going to write my different y values, but I don't need to repeat these, so I'm just going to put -1, 3, and 6. And then what you do is you basically use a line with an arrow to show which domain value goes with which range. So I have -1 with 3, so from -1 I just draw an arrow to 3, and that means those two are an ordered pair. I have 0 with 6, so I just draw a line from 0 to 6. I have 4, -1, so I draw a line up to -1, and then I have 7 with 3, so I end up having 2 different lines pointing to 3, which just shows that you have 2 different domain values with the same range. So you have this example on your notes, and you actually have the ordered pairs already written on your notes, so I'm just going to copy those. So we have 3, 4, we have -1, 2, and then 0, -6. So if you want to fill in your table and fill in your mapping right now, so you can press pause and then press play when you want to check those, and then we'll look at how the graph should go right after that. Okay, so it's important when you do your table that you don't have to put this numerically least to greatest. You have to make sure you align what you've seen in the ordered pairs the same way in the table. So if I had an ordered pair 3 and 4, I need 3 and 4 to be next to each other in the table, -1 with 2, and then 0 with -6. So that part is important. With your mapping, you're typically going to see the mapping in numerical order. So my 3 x values in my domain were -1, 0, and 3, and that is numerical. And then with my y values, I had a -6, 2, and 4. And the reason why you can keep these in numerical is because your arrows are going to, they can go in different ways. So you don't have to have your 3 and 4 right across from each other, although they happen to work out that way, because you're drawing a line and the line can crisscross like you see in the mapping. So your mapping might not look like this, but as long as you have your arrows going to the right numbers to make that ordered pair, it's okay. So the graphing literally is just graphing these ordered pairs. So if we wanted to graph 3, 4, then we're just literally going to go to +3 for x, +4 for y, and we're going to put a dot. If we want -1, 2, we go to -1 for x, +2 for y, and put a dot. And then 0, -6 would be no movement on the x-axis and all the way down to -6. And that's basically it for your mapping. And now you see all 4 representations of this relation that we started with. So all of this talk about relations is going to tie into talking about functions. So we're going to take a look at what a function is next. So your definition of a function here is kind of lengthy. You can pick and choose what you want to put, but the real definition up top, please write, it's a relation in which each element of the domain, so that's your x values, is paired with exactly one element of the range, which is your y values. Now the starred stuff are just different things to maybe help you identify these, maybe in easier wording. So if you want to include that, you can. First star basically kind of just summarizes what we just read. It basically says that every x value can be paired with only one y value, which means if you have an x like 2, then it needs to be with a specific y value. Shortcut for how to look for functions is if there are duplicate x values, so if you have the same x value twice, it has to be with the same y value to be a function. And also it says if there are no duplicate x values, then you automatically have a function. So again, the whole talk about functions deals with your domain or your x values. If you have a repeated x value, if it has the same y value that it's with, it's good. But if it has a different y value, like if you have 2, 3 and then 2, 4, it's not a function. So we have some examples down on underneath your definition of function. There's nothing for you to actually do on here, but basically, again, that shortcut says look at all the x values. If any values are the same, they must have the same y value to be a function. So if I was just looking through these and my functions on the left side, I've got -3, 5, 7. Since none of those repeat, then that's great. It's already a function. And then your second 3, you have a 0, a 3, and then a 0. So typically you red flag when you see 0 and then 0. Which means you have to look at the value that it's with. And because they're both with the same y, then again, that's automatically good to go. Not functions, I have -5, 0, 0, but then when you look at the values that those two 0 ordered pairs are with, since they're different, no good. And then your second one, 1, 1, 2. And then again, if you look at those two 1s when they're with different y values, then again, it's not a function. So on the back of your notes, there's a few practice ones on here. If you want to try and identify whether these are functions or not, you could just put yes or no on there. You could press pause, try them on your own, and then press play when you want to check how you did. So number 1 should be yes, no repeating domain automatically makes it a function. 2 was no because we had those two 9s with different y values. 3 was also no because we had two 3s with different y values. And then 4 was a table, but if you looked at the x's, you had that repeating -3 with two different y values, so that was also no. So the last thing we're going to look at is determining if you have a function based off of a graph. And if you remember this from last year, it's actually really, really easy. So what we're going to do for these is basically use what we call a vertical line test, and the vertical line test proves or states if any vertical line passes through only one point of the graph at any relation, then it is a function. And again, why we do a vertical line test is if you think of your coordinate plane, here's x, here's y, and let me just make a mini graph. But by drawing a vertical line vertical is going to hit those x values. So if I needed to kind of list the x value of this one I'm making up, maybe it's like at 3, and it's only going through this blue graph one time, which means it only goes through that x value at one different point. And since functions are all about the x repeating or not repeating, that's why we were able to use a vertical line to help us out with that. So your two examples at the bottom, what you see on your notes, you have this first example, and if I randomly just draw some vertical lines, and you can draw them wherever you want. You can do them in as many places as you want to, but that very first one I drew, I actually see that it goes through this black graph in 3 different spots. And if I listed those ordered pairs, that means there's 3 ordered pairs that are at -4, but they have different heights or different range or y values that you see. So this first one is not a function because it doesn't pass the vertical line test. The second one, if I start drawing some vertical lines through this black line, I can clearly see that it's never going to go through that black line in more than one spot. So this one is a function because it passes the vertical line test. There's no repeating x values with different y's. So here's just a couple extra looks. These aren't in your notes, but again, the black lines are the vertical line test. The red is the actual graph, and the blue was the x and y axis. And that first one, if you look at, it would pass the vertical line test, so yes, it's a function. The second one, the black line never goes through more than once, so yes, and this third oval clearly not, because I could see where these black lines are going through more than one spot. And then last, just a couple more. Function for this top one, because the vertical line never goes through the red line more than once. This second one, you actually can't even really see where the red line was, but it was actually a vertical line right here, and whenever I drew a vertical line over it, it clearly covers it, so this is not a function. This third one, not a function, because you can see that the black line cuts through twice, and this last one is a function because even though it's curved, it's never curved in a way that you're going to have a vertical line touch it more than once. So that's it for notes. We're actually going to finish the last section of your notes next time I see you guys, so just bring this to class with you and you are good to go.